All right, here is flipped number 2. In class, we talked about the sides and some of the angles that we understood. We talked about how we can identify shapes based on the number of sides that they have. We haven't talked a lot about angles, and we haven't talked a lot about lines. So that's where we're going to go today. And angles and lines make us even more specific when we're actually naming polygons. So here we go. All right, first, let's identify what an angle even is. Okay, an angle is when you have a shape, okay, and we have sides that intersect. Okay, so right here would be one location that I have an angle. I also have an angle here, and I have an angle here, and I have an angle here. And that angle just is how open or how far apart those lines are. Okay, so here I have all the way from here to here. And then here I have, it's a larger angle. All right, so let's kind of give a more specific name to those angles based on how big they are. All right, so the first angle that I have is an obtuse angle. And I say it in that really deep, big voice because an obtuse angle is a really big angle, okay? So if I look at it, my angle is going all the way from right here, and it opens all the way around. Do you see how big that is? Okay, that's what makes it an obtuse angle. Okay, so if you see an angle that is really, really big or really, really wide, you're going to know that that's an obtuse angle. My next angle is an acute angle. It's just a cute little angle. So if I look at this angle, my cute little angle, and it still starts right here. So if I still start down here, I only have this little bit to travel to get to the end. So that's why it's a cute little angle. It's an acute angle. Say acute. Acute angle. Very, very good. All right. Okay, my last angle is a right angle. And we kind of talked about this today or yesterday during class, but I didn't explain a whole lot about what it was because I knew you were going to watch this video. Now, a right angle is where we have two lines that come together and they form that perfect corner. It's like if you could stick your corner of your paper into it and have it fit perfectly. That's when it's a right angle. And you'll notice that each of these has that little box in the corner. And that shows that even if you draw it, because, if Mrs. Martin were to draw a square and try and make it right angles, those aren't exactly perfect. But I can draw that square and you know now that I'm wanting that to be a right angle. Okay? A right angle is just that perfect corner. It's 90 degrees. All right, I want you to kind of sketch these 6 angles on your paper somewhere in your summary section. I don't care where. It could even be on the back. And I want you to label what each of those angles is. So I want you to pause the video. And when you get finished pausing the video, I will go over the answers with you. So take a second and pause it. Okay, here's your answers. This angle is a cute little angle. So you should have written acute. Okay. This next one is the same thing. You should have written acute next to it. This one right here is a right angle. Okay. I always think of right as perfect. It's a perfect corner. It's the correct way. It's right. It's just absolutely perfect. That's how I remember. This one is another little acute angle. And an acute angle. That one's really close because it looks like it could be right, but it's not all the way there. Do you see how these lines aren't pixelated, but this one kind of looks like it does a little jaggedy? Okay, that's how we know that they aren't exactly perfect in this particular picture. And then this last one here is an obtuse angle. So you should have written obtuse. Okay. And from here on out, I would expect that your spelling is correct. Acute is just A and then the word cute next to it. Right, you should be spelling correctly anyway. And then obtuse is just the O-B and then T-U-S-E, tuse. It kind of looks like it sounds. All right? All right, I have put up some shapes here, and I want you to determine in these polygons what angles you see. So I want you to find one of each of the 3 kinds of angles, and I want you to label it. So you can just pick, maybe you can do it in a couple of shapes, or maybe you need all the shapes. But choose those polygons, label them, and then be ready to discuss that when we come back. So now that we know what kind of angles we have, let's look at how we can look at lines or use lines to create those angles, okay? So we're going to have some different sets of lines that do some different things for us. So let's categorize those. All right, now we're going to jump into perpendicular lines first because they are the closest to right angles. If I told you that I wanted you to draw 2 lines that came together and created a right angle, try that. If you wound up drawing something like this, where you have a right angle, you drew perpendicular lines. So here, let me show you a more specific example. All right, so basically all you need is those straight lines that form this right angle right here, okay? If you can fit a piece of paper into the angle, it's a right angle and you've created perpendicular lines. Now, you could have lines that only go until they touch. So you could have 2 lines like this, and those are still considered perpendicular lines. All right, parallel lines are the complete opposite of this. Parallel lines are going to do something that reminds me of these 2 L's, okay? If you look at those 2 L's, what do you notice about them? What's one observation you can make? The observation that I want you to make is that this L, if it keeps going, and this L, if you kept going, would never touch each other, would they? They're exactly the same distance apart no matter how far away they are. Those are parallel lines. So that's how we remember parallel lines, is they have a set of parallel lines in the word. So let's look at a more specific picture. All right, so here's my set of professionally done parallel lines. If you look, they will never ever touch each other, ever. I can turn them this way, I could twist them this way. You can have lines that go straight up and down, but all the while, they never change their distance. And if I were to extend them out, I'll do it, and it may not be totally straight just because on technology it doesn't always work perfectly. But if I extend this out, and I extend this one out, they won't ever touch. They could go clear off of my iPad. They can keep going. They could go in this direction off my iPad. They could go and wrap themselves all the way around the room, but they would never ever touch, and that's what a parallel line is. Lastly, we have intersecting lines. And intersecting lines are those lines that may not be exactly perpendicular or they may not be exactly parallel, but at some point they're going to touch. So if I have them and I go from, here, and then maybe I have another one that's here. So I go maybe this general direction, okay? Here is my intersection point, okay? So at this point, they touch and would intersect. So here I have my obtuse angle, okay? Also, I can make acute angles over here. If I wanted another set of intersecting lines, perpendicular lines are technically intersecting lines. They're just the ones that form the 90-degree angle. If I wanted just these 2, I could also have the ones from any kind of shape. So if I have a polygon like this is a set of intersecting lines, this is a set of intersecting lines, and so on. So every vertice or angle is my set of intersecting lines. So if you have an angle, you have an intersecting line. All right, that was kind of a whirlwind tour of angles and lines. I want you to be ready to add to your builder's log tomorrow when you come back and we're ready to discuss it. We're going to add some qualities of rectangles and parallelograms and things like that that tell us more detail, because now we know what kind of angles those things have to have and what kind of lines those polygons have to have. I'm excited to see you, and we will discuss this tomorrow.